folks, welcome to examples 5 and 6. So similar to the equations before us, or the examples before this, I'm going to find the LCD for both of these equations, this rational equation and this rational equation, and then I'm going to multiply every term by that LCD to knock out the fractions. And you might say, well, there's not a fraction here with this number 1. There secretly is. We can make anything a fraction if we make that denominator 1. So let's take a look at the LCD here. Number-wise, I just have 5 and 1, so I will cover my bases with the number 5. And variable, right, I just have this factor of x, and they're both raised to the first power, so my LCD is just going to be 5x. Over here, let's see what we have LCD-wise. Okay, so numbers, I have 6, 2, and 6. I will cover my bases with 6. And if I look at my only other factor, it's just x. Here I have x squared, x to the 1, x squared. And when you're building your LCD, you always take that highest exponent. So my LCD here is going to be 6x squared. And again, I'm going to write small because there's not a ton of room, but I'm going to multiply 5x to every term in this equation, and then 6x squared when I get there to every term in equation 6. So let's do number 5. So I'm going to do 5x to 1 over x. That should be 5x times 6 over 5x plus 5x times 1. And then things will cancel. So I can see the x's cancel here, the 5x's cancel here, and there's nothing to cancel in this last term because, yeah, I can write it as a fraction with 1 over 1, but it's really not a fraction. So let's see what we have left over. We have 5 times 1, which is 5. I have 6 here, and 5x times 1 is 5x. I have a linear equation, so I'm going to go ahead and just solve for x. All right, so if I take a look at this, I'm going to subtract 6 from both sides. All right, and then I am looking at 5x being equal to -1. And I personally like to write my variable on the left-hand side. So yes, that canceled out and technically left me with a 5x on the right and a -1 on the left. But I like to just flip-flop those. Okay? All right, so then let's go ahead. Oops, I think I shifted my worksheet just a little bit. And let's go ahead and divide both sides by 5. So I get a division of 5, x is going to be equal to -1/5. And if I look, that doesn't zero out any denominator, so I'm going to go ahead and keep this answer. All right, so let's go ahead and multiply every term in equation 6 by 6x squared. So we're going to have 6x squared, 1 over 6x squared equals to 6x squared times 1 over 2x. Plus 6x squared times 7 over 6x squared. All right, let's see what happens when we cancel. All of this will go away. And actually I can see all of this last term will go away. This I gotta cancel a little. So I'm gonna have 6 over 2, which would leave me with a 3. I'm gonna have x squared, or I should say x squared over x, which will leave me with an x. So I have 1, that's equal to 3x plus 7, right? So I have 1 equaling 3x plus 7, linear equation. Let me subtract 7 from both sides. And again, when I do this, I'm going to write the 3x over here, and then 1 minus 7 is -6. And all I need to do at this point is divide both sides by 2. Nope, not by 2, by 3. And that's going to give me x equaling -2. And when I think about x equaling -2, it doesn't zero out any of my denominators. So I'm going to go ahead and keep that for an answer. All right, thanks so much. Bye.